Good morning, everyone. Today we are going to solve economic load dispatch problem. In that problem, here what they asked is loss per hour. So here they ask loss per hour if the unit operated with equal loading like that they ask. So take down this problem. The cost characteristics of three units in a power plant are given by C1 is equal to zero point 0.5 P1 square plus 220 P1 plus 1800 rupees per hour. C2 is equal to zero point 0.6 P2 square plus 160 P2 plus 1000 rupees per hour. Then C3 is equal to 1 P3 square plus 100 P3 plus 1000 plus 2000 rupees per hour. That P1, P2, and P3 are generating powers in megawatt. Maximum and minimum loads on each units are 125 megawatt and 20 megawatt respectively. Maximum and minimum loads on each units that is given. Minimum and maximum operating limits is given. So simply what they said is obtain the economic dispatch when the total load is 260 megawatt. And again, they asked what will be the loss per hour if the units are operated with equal loading. So here they are asking the total loss. So the problem is very simple, but here like while reading the problem, it seems to be confusing. But loss per hour they ask. That's all. So here for three generating units, here what I am doing is I'm solving with lambda iteration method because it's very simple. So the formula for calculating lambda is equal to PD plus summation I is equal to 1 to n bi divided by 2ai, the whole divided by summation I is equal to 1 to n, 1 divided by 2ai. So here, as I said before, first you need to mark what is A1, B1, C1, A2, B2, C2, A3, B3, C2. So here what we are doing is simply we are substituting what are the fuel cost coefficients in this equation. After substituting, we are getting the equation like this. Simplifying, we are getting the lambda value as 284.2885 rupees per megawatt hour. Next, we have to calculate PI. PI is equal to lambda minus BI divided by 2AI. So lambda already we calculated minus BI divided by 2AI. So that is B1 divided by 2A1. So B1 from the problem data, it is given as 220 divided by here A1 is given as B1 is 220, A1 is 0.5. Just we are substituting here and simplifying, we are getting the P1 answer as 64.2885 megawatt. That is power generated one. Similarly, P2. P2 what? Similarly, same formula, lambda minus B2 divided by 2A2. From the problem, B2 is given as, B2 is given as 160 and A2 is 0.6. Simply, we are substituting here B2 and A2. So here we are getting P2 as 103.57 megawatt. Similarly, P3 lambda minus B3 divided by 2A3. So B3 is given from the problem as 100 and 2A3. A3 it is given as 1. While simplifying, we are getting the answer as 92.144 megawatt. And always you need to check for the limits, minimum and maximum operating limits given in the problem. If it is not given, just no need. But it is given in the problem. Maximum and minimum loads on each unit is 125 megawatt and 20 megawatt. Here, after calculating P1, P2, P3, here I am taking all the answers here. And we are checking for the minimum and maximum operating limits. That is 20 megawatt less than or equal to P1, P2, P3 up to 125 megawatt. Here power generating units P1, P2, and P3 satisfies the demand and also it satisfies the minimum and maximum loading limits. So while doing the demand, what is the demand given is 260 megawatt is the demand given. 260 megawatt. So we are getting approximately 260. It is 259.59, 259.999 like that we are getting. It is approximately equal to 260 megawatt. It is satisfying the demand and also it is within the limit. That is all the generating units that is within the 20 megawatt and 125 megawatt. Yeah. So this condition satisfies. Now economic dispatch we are telling, but what is the case to what is asked in the problem? Actually, economic schedule they asked that we have calculated. That is the first part. Next part is they asked to calculate the loss per hour. Loss per hour if the units are operated with equal loading. So equal loading in the sense all three generating units are in the same power demand is 260 megawatt. We are taking the power demand as 260 megawatt. That is P1 plus P2 plus P3 is equal to 260 megawatt. So equal loading is all P1 is equal to P2 is equal to P3. So 260 divided by 3 is nothing but 86.67 megawatt. 86.67 megawatt should be the all. That is P1 is equal to 86.67 megawatt, P2 is equal to 86.67 megawatt, and P3 is equal to 86.67 megawatt. If you add all these things, we are getting 260 megawatt. By substituting the above values of P1, P2 and P3 in the cost characteristics, so we are getting cost C1 as so while substituting C1, what is C1 equation given as? C1 is equal to 0.5 P1 square plus 220 P1 plus 1,800 rupees per hour. So here we are substituting P1, whatever we calculated, that is 86.67. So while substituting, we are getting the cost C1 is equal to 24623.24 rupees per hour. Similarly, C2 also in the cost equation, we are substituting 86.67 megawatt because P2 is 86.67 megawatt. So while substituting, we are calculating C2 as 19374.21 rupees per hour. Similarly, C3 also P3 we calculate as 86.67 megawatt. So 1 into 86.67 the whole square plus 100 into 86.67 plus 2000. Here we are calculating C3 cost fuel cost 3. Okay, so fuel cost 3 we are calculating. So 18178.68 rupees per hour. Now total cost is nothing but C1 plus C2 plus C3. Adding all C1 plus C2 plus C3, we are getting the answer as 62,176.1389 rupees per hour. This is the total cost when the units are operated with the equal loading. Similarly, with the economic dispatch value, already we calculated in the previously. Yeah, with the economic load dispatch value, similarly, we are calculating the cost C1, C2, and C3. With the economic dispatch value, that is P1 is equal to 64.2885 megawatt, P2 is equal to 103.57 megawatt, and P3 is equal to 92.144 megawatt. So from these economic load dispatch values, we are finding out the cost, first cost. Fuel cost 1, C1 is equal to the same fuel cost characteristics. So we are just substituting and we are getting the answer as 18007.55 rupees per hour. Similarly, the cost 2, fuel cost 2, while substituting P2 as 103.57 megawatt. Here we are substituting and we are getting the answer as 24007.24 rupees per hour. This is the cost 2 we are getting. Similarly, cost 3 we are in the cost equation, we are substituting that is P3 as 93 point. Here P3 as 92.144 megawatt. Here we are substituting in the cost 3 equation and simplify, we are getting the 19703.77 rupees per hour. The total cost we are calculating C1 plus C2 plus C3. Here we are getting 61,718. 61,718.5696 rupees per hour. We are getting as total cost for economic load dispatch value. But by comparing the total cost of economic load dispatch value and with that equal loading. So economic load dispatch only we are getting the least cost, while compared to the normal with the equal load. So here for the economic load dispatch, the total cost is less than when compared to the total cost when units are operated with the equal loading. So obviously, because that is the economic load dispatch. So from this cost, total cost, we can easily compare this the economic load dispatch cost. Okay. So we got the economic load dispatch. From the economic load dispatch, we are finding out the cost. So that cost only we are getting less. So that you need to remember. Now what asked in the problem is loss incurred. Loss incurred is the whatever the total cost while calculating with the economic load dispatch value and the total cost we calculated from the equal loading. The unit operated with the equal loading. That's the two costs we are making the difference. We are doing the difference here, and we are that is the losses. That is the losses we are getting this 457.5693 rupees per hour. That is the loss incurred. That is what asked in the problem. So two things they asked in the problem. The first one is, yeah, here it is economic load dispatch value for 260 megawatt that we have calculated P1, P2, P3. And second one, they asked what is the loss per hour if the units are operated with the equal loading. With the equal loading also, while taking the equal loading for 260 megawatt, that also total cost we are calculating. After that, how to find out the loss in the sense that difference between the total cost that calculated from the equal loading and the total cost from the economic load dispatch value, that we are getting thus some value, some 4,000, yeah, 457.5693 rupees per hour. So you just tell in the comment whether you are also getting the same answer or not. Thank you.